Okay, a very quick one. You don't need to know this for the exam at all, but if we said that the discharge pattern is given by E to the minus T over RC, that the charging pattern is given by 1 minus E to the minus T over RC. I'm going to very quickly go through it just for the purists of you. So in order to understand where this comes from, you have to think about the energy that's going on in a charging circuit like this. So the energy being given to the circuit is basically the potential difference of the cells times by any charge that goes through them. The energy being taken out of the circuit is the potential difference across the resistor plus the potential difference across the capacitor, which I'm going to call VC for now. And it stands to reason that V0 is going to be equal to VR plus VC. Or, precisely, more to our interest, we can say that VC, or the voltage at any point, is going to be given by V0 minus VR. Okay, and that's the key thing we're going to start with. So from there, let's start substituting. We know, I'm just going to call it V from now because that's what we're going to get to. The voltage at any point across the capacitors, V, is given by the initial voltage, V0, minus VR. Now VR at any point is going to be I times R. Okay. Now we also know that at any stage, any current, I is equal to I0 e to the minus t over RC. So I can put the 0 in there, so I can sub this in for the current there at any point in the cycle. Okay, so I'm going to say V equals V0 minus I0 e to the minus t over RC, all times by R, because I'm just substituting this slot for this I here. Okay, that's true at any stage in the cycle. Okie dokie, with that in mind, I can say, well, what is I0? Well, if I0, if at the start of it, the current that's flowing through here, if V0, when it first starts charging, the current, because this has got no potential across it at the very start, this hasn't built up any charge, has it? So the start, before this builds up any charge, and before it builds up any potential difference, the initial PD V0 across the power supply is going to be equal to the initial current I0 across the resistor. Okay, because it's just at the very start, this hasn't got any PD across it at all. And so as a result, I can now substitute, I can rearrange this and say I0 equals V0 over R. Because I can do that, I can chuck that in up here. So I end up with V equals V0 minus V0 over R times by E to the minus T all over RC all times by R. And you can see straight away the two R's cancel each other out, which is great news for us, and we end up with V equals V0 minus V0 e to the minus t over RC. Of course this, I think you can see where this is going, V becomes V0 1 minus e to the minus t over RC. Ka-ching. So with that, I mean, again, you don't need to know this where it comes from, just like you don't need to know where you don't need to know this comes from or where this comes from, but that's the maths behind it. Okay, so just for fun.